The Yellowstone caldera is vast, 45 miles across and 30 miles wide. You could fit over 60 islands of Manhattan in this area.
Deep beneath the serene wilderness of Wyoming, something ancient is stirring. Yellowstone National Park, the crown jewel of the American West, is trembling under a hidden force. Steam drifts through the pine forests, geysers erupt on schedule, and tourists laugh as cameras click. To the naked eye, everything seems normal. But scientists watching from underground sensors and satellites know better. The ground is shifting, the gases are rising, and for the first time in decades, the United States Geological Survey has triggered a red alert, the highest level of volcanic warning. That alert, issued quietly at first, has since echoed around the world. The Yellowstone supervolcano, long thought to be dormant, may be entering a new and dangerous phase. It's been roughly 640,000 years since its last eruption, an event that reshaped the North American landscape and darkened skies across the planet. Now, the question haunting geologists everywhere is simple. Is it waking up again? The park's famous calm beauty has become a mask for unimaginable pressure below. Each tremor, each burst of gas, each centimeter of uplift hints that Earth's oldest furnace is stirring back to life. What happens next could change the world, because when Yellowstone breathes, the planet listens. Yellowstone is more than a national park. It's a living scar on the surface of a planet that never truly cools. Beneath its forests, lakes, and geysers lies a colossal engine of molten rock, a supervolcano so vast that it defies imagination. From space, the caldera appears as a broad, shallow depression, nearly 45 miles wide, surrounded by mountain ranges that once formed its rim. It's not a crater from impact or erosion, but a wound carved by explosions powerful enough to alter the course of history long before humanity existed. The Yellowstone caldera is one of Earth's most closely monitored geological features. Networks of seismographs and GPS stations ring the park, constantly measuring every twitch, every whisper from below. For decades, scientists believed they understood its rhythm. The volcano breathed slowly, pressure building, and fading in a natural cycle of geothermal equilibrium. But in recent months, that rhythm has changed. It began with a subtle uptick in tremors, dozens of minor quakes in early spring, then hundreds by midsummer. At first, this was routine. Yellowstone averages between 700 and 3,000 small earthquakes every year. But these swarms were different. They came in bursts of shallow, tightly clustered quakes, centered near Norris Geyser Basin, the park's most thermally active region. Some swarms lasted minutes, others hours, and each one rattled the ground like a pulse from below. Scientists began cross-checking data. GPS sensors showed measurable uplift of nearly 15 centimeters across several monitoring sites, the kind of ground deformation that occurs when magma pushes upward. Seismic waves revealed low-frequency vibrations consistent with fluid movement, suggesting molten rock or gas was migrating through cracks in the crust. Then came the gas. Instruments stationed across the park detected sharp spikes in carbon dioxide, sulfur dioxide, and hydrogen sulfide, each a chemical fingerprint of magma degassing at shallow depth. These gases seeped through soil, bubbling up from springs and vents, leaving behind the acrid scent of sulfur and metallic tang of minerals. Even the geysers began behaving strangely. Old Faithful, once as reliable as clockwork, began missing eruptions. Steamboat Geyser, the tallest in the world, suddenly surged to life, erupting with a force unseen in years. For geologists, these were not coincidences. They were clues. Beneath Yellowstone's surface, something massive was moving. The crust was flexing like the lid of a pot under pressure. And though no one could yet say how close the system was to eruption, one fact was beyond doubt. The world's most powerful volcano was no longer at rest. Volcanoes don't erupt without warning. They evolve toward eruption in stages, and Yellowstone is following that pattern step by step. The first stage is seismic unrest, and it's already underway. Hundreds of small earthquakes have rippled across the caldera, each one a whisper of magma shifting through fractures miles below. Together, they form earthquake swarms, clusters that rise, fade, and then rise again. These aren't caused by tectonic plates grinding, but by molten rock forcing its way upward, cracking the Earth's brittle crust. The second stage is gas release, And Yellowstone has entered that phase too. Gas monitoring stations are recording record-breaking emissions of sulfur dioxide, carbon dioxide, and helium-3. The latter, a rare isotope found in magma, rising directly from the mantle. Sulfur dioxide, in particular, acts as a thermometer of magma movement. When levels spike, it means molten rock is nearing the surface, venting its contents into the air. The third warning is heat, and satellites have now confirmed elevated surface temperatures in areas never previously recorded as active. Entire sections of forest show unusual warmth in infrared scans. Snow melts weeks earlier. Springs once lukewarm now reach boiling point. New fumaroles, steam vents, have opened overnight, spewing superheated gas that hisses through cracks like the exhale of something buried alive. Deep within the U.S. Geological Survey's control room, teams work in shifts around the clock. Rows of screens display live readouts from sensors buried in the park. Pressure data, heat flux, gas composition. Scientists huddle over monitors, debating patterns, comparing them to known eruption precursors from volcanoes in Hawaii, Iceland, and Indonesia. This is the most active we've seen Yellowstone in our lifetime, one volcanologist admits. Seismic data show that many of the recent quakes are shallow, just 3 to 5 kilometers beneath the surface, a sign that magma is intruding into the upper crust. Thermal imagery reveals widening hotspots, expanding faster than natural geothermal variation would explain. Satellite instruments track not just temperature, but infrared anomalies, ghostly fingerprints of heat spreading like veins beneath the park. Even the color of some geysers has shifted. The Grand Prismatic Spring, Yellowstone's most photographed wonder, appears slightly greener, a sign of altered microbial life responding to temperature and chemical change. The changes extend beyond sensors. Rangers report wildlife acting erratically, elk herds abandoning traditional grazing grounds, wolves traveling farther north, birds avoiding nesting near thermal areas. While anecdotal, these behaviors align with known pre-eruption phenomena. Animals detect gas changes and vibrations long before humans can. Each of these signs, tremors, gases, heat, uplift, animal movement, may seem minor alone, but together they form a symphony of unrest, a complex prelude that scientists recognize all too well. It's not panic that drives them, it's awareness. Yellowstone's last eruption changed the face of a continent, and now, after 70 millennia of silence, the same forces are again pressing against the fragile crust that keeps them contained. One researcher described it best. "We're not predicting doom," he said quietly, eyes fixed on the monitors. "We're watching a sleeping giant turn in its bed, and every movement reminds us how small we really are. To understand why Yellowstone matters, you must first understand what it is. Beneath the peaceful lakes and pine forests lies one of the largest magma reservoirs ever discovered. Stretching dozens of miles wide and several miles deep, it holds more than 46,000 cubic kilometers of molten rock, enough to fill multiple Grand Canyons. Unlike the towering cones of Mount Fuji or Vesuvius, Yellowstone's volcano doesn't rise. It collapsed. Its vast caldera was formed by 3 cataclysmic explosions, the first 2.1 million years ago, the second 1.3 million years ago, and the third 640,000 years ago. Each eruption hurled ash thousands of miles, altering weather patterns, killing species, and cooling the planet for decades. If you stood here then, you would have watched continents darken beneath a sky of ash. That was not just an eruption. It was a planetary event. Since then, Yellowstone has rebuilt itself in silence, its magma chamber refilling like a lung. The geysers, springs, and fumaroles we marvel at today are its safety valves, releasing tiny breaths of pressure from the depths. But when that pressure finds no escape, the system resets violently, and the results can rewrite geography. For decades, Yellowstone has been stable, until now. New satellite radar imagery shows the land swelling unevenly, as if the Earth itself is inhaling. The crust is warping, bending under internal strain. Some scientists call it magmatic inflation. Others call it the dragon stirring. Seismic tomography, essentially an X-ray of the planet, now reveals fresh magma intrusions into the upper chamber. These intrusions are like molten arteries, feeding heat and pressure into the system. The deeper layers are rising faster than expected, pushing the crust outward in waves. Even the natural world seems unsettled. Bison have been seen migrating earlier than usual, herds moving in strange directions. Birds are abandoning familiar valleys. Streams once clear now run cloudy with minerals shaken loose by underground heat. Geysers like Old Faithful have missed eruptions for the first time in decades, their timing disrupted by changes in pressure. It's as if Yellowstone itself is preparing for something, a release, a reset, or something far more powerful. The equilibrium that has held for centuries is starting to falter, and every new reading suggests the earth below is no longer content to stay quiet. When the red alert announcement broke, the world reacted instantly. Social media filled with panic, rumors, and viral clips claiming Yellowstone is about to blow. Drone footage of steam vents, migrating animals, and glowing geysers spread like wildfire. Overnight, hashtags like #YellowstoneEruption and #Apocalypse2025 trended across platforms. News anchors spoke in tense tones. Commentators compared it to Pompeii, or worse. But in laboratories and control centers, the tone was different. Calm, focused, determined. Scientists at the Yellowstone Volcano Observatory knew that fear spreads faster than lava. They issued public statements, assuring that a red alert does not equal an immediate eruption. It is instead a declaration of maximum monitoring, meaning conditions are volatile enough to require round-the-clock watch, but not yet beyond control. Still, it's easy to see why the public panicked. The term red alert has rarely been used in U.S. volcanic history, and when people hear that phrase tied to the largest volcanic system in North America, they imagine the worst. Yet volcanologists are careful. They know prediction is a fragile science. Many emphasize that Yellowstone could remain restless for years or even centuries without erupting. Meanwhile, scientists on the ground have turned the park into a living laboratory. Dozens of new seismometers have been installed. Airborne drones equipped with infrared sensors track heat anomalies in real time. Every puff of steam, every shift in gas composition, every irregular geyser eruption is logged and compared against decades of records. Their work is painstaking, but essential. Each new data point helps separate signal from noise, the natural breathing of the earth from the warning signs of catastrophe. And through it all, the balance between science and speculation hangs by a thread. Because one misinterpreted pattern, one premature conclusion, could cause unnecessary panic, or worse, false reassurance. By the end of the week, USGS teams had briefed Congress, international observatories, and even the White House. "We're not predicting eruption," one scientist said. "We're reading a conversation, one between the Earth and itself. And right now, it's getting louder." Imagine this. Within hours of an eruption, the sky turns black. A wall of ash rises 20 miles high, spreading eastward across the United States. The sun fades to a dim orange disk. Within days, ash falls like snow in cities as far as Chicago and St. Louis. Within weeks, global air temperatures drop. The world enters what scientists call a volcanic winter. That is not science fiction. It's geological precedent. The last time Yellowstone erupted, around 640,000 years ago, it ejected 1,000 cubic kilometers of volcanic material. To put that into perspective, it's enough ash to bury New York City under a layer more than 70 feet deep. Even a fraction of that would devastate modern civilization. A super eruption would render large swaths of North America uninhabitable. Croplands would be destroyed, rivers contaminated, air travel grounded for months. Volcanic ash is fine as talcum powder, but sharper than glass. Inhaling it can scar lungs. Electrical grids would fail as lines collapse under ash weight. Supply chains would break, and as sunlight dims, global agriculture would wither, leading to famine and migration crises on a scale the world has never seen. But even smaller events carry danger. Hydrothermal explosions, triggered when boiling water trapped under rock flashes to steam, could strike without warning. These blasts can hurl debris hundreds of feet into the air, carving new craters overnight. Scientists warn that such explosions have occurred before in Yellowstone, and may already be increasing in frequency. And yet, there's perspective in the chaos. Statistically, the odds of a full-scale eruption in any given century are exceedingly low. But low odds do not mean no risk. For the people who live near Yellowstone, in Gardner, Cody, or Bozeman. The uncertainty itself is the danger. They wake to trembling earth and headlines that ask if tomorrow might be the day. For them, the supervolcano isn't a global headline. It's home. The moment Yellowstone's alert went public, the entire scientific world mobilized. Within hours, NASA adjusted its Earth-observing satellites to focus on the region. Japan's JAXA and Europe's Copernicus program began cross-referencing satellite imagery for heat signatures. Supercomputers from Los Alamos to Geneva were repurposed to simulate atmospheric fallout scenarios. In Iceland, volcanologists offered expertise in gas venting and magma migration. Italy's Etna Observatory shared real-time algorithms for eruption probability. For the first time in human history, a single volcano became a global collaborative project. Data poured into an international dashboard updated every minute. Seismic charts, thermal readings, and gas spectra painted an intricate portrait of Yellowstone's behavior. Meanwhile, world governments were anything but idle. The U.S. Department of Homeland Security began drafting contingency plans for worst-case scenarios. FEMA expanded emergency shelters across western states. The CDC issued preliminary guidelines for respiratory safety in case of ashfall. The Department of Agriculture began researching crop resilience to sunlight reduction. Even stock markets reacted. Energy and food commodities spiked overnight. But the most fascinating development came from NASA's Planetary Defense Division. Engineers there proposed theoretical ways to cool the magma chamber gradually, not with explosives, but with directed geothermal energy extraction. By drilling near the edges of the caldera, they suggested it might be possible to bleed heat slowly, like easing pressure from a boiling pot. It remains theoretical, risky, controversial, and possibly impossible. But it shows how desperate humanity is to prepare. In the background, quiet diplomacy unfolded. Nations across the Pacific Rim and Europe shared airspace monitoring data. China pledged satellite coverage. Canada offered cross-border emergency response. Yellowstone's restlessness had, for a moment, united humanity in vigilance, a rare harmony born from shared vulnerability. The global message became clear. We are not fighting Yellowstone. We are simply learning to listen to it. While scientists measure tremors and gases, others listen in older ways. For the native nations who have lived around Yellowstone for millennia, the Shoshone, the Crow, the Bannock, the land is not a danger to be feared, but a spirit to be respected. Their oral histories speak of cycles of fire and renewal, of the mountain that breathes and the ground that dreams beneath sleep. To them, what scientists call a caldera is a living being, one that occasionally stirs to remind humanity of balance. When they see the new fumaroles hissing or feel the trembling earth, they interpret it not as destruction, but conversation. The earth, they say, is speaking. Modern researchers have begun to see wisdom in that worldview. Yellowstone is not just a volcano. It's a system, a living network of pressure, water, gas, and heat in constant motion. The park acts like a single organism, every geyser and spring responding to subtle internal changes. In recent weeks, some features have turned erratic. Springs once turquoise now run a milky white. Pools once calm now churn like boiling cauldrons. Magnetometers have detected abrupt flips in the magnetic field, the kind that often accompany molten rock moving closer to the crust. Small animal migrations, elk herds shifting routes, birds avoiding nesting grounds, mirror these disturbances. Even the forest floor has changed, venting gas through new cracks invisible to the naked eye. And through all of it, nature seems to know something we don't. The bison graze restlessly. The rivers hiss. The soil smells faintly of sulfur, sharp, metallic, ancient. The stories of indigenous elders and the readings of modern instruments converge on a single truth. Yellowstone is alive. It is not a monster waiting to destroy us, but a reminder that creation and destruction, birth and extinction are all part of the same planetary rhythm. The same fire that once built the mountains still burns beneath our feet. Night falls over Yellowstone. Under the dim silver of the moon, steam drifts lazily through the valleys, glowing like ghostly ribbons. Geysers erupt in silence, their mist catching the light like smoke from unseen fires. The land seems asleep, but it isn't. Instruments buried deep below still hum with readings. Faint tremors, irregular heat signatures, whispers of a planet alive and aware. In a small control room outside the park, scientists from around the world remain awake. Coffee cups sit beside flickering monitors as data scrolls across the screens. Seismic waves, gas ratios, satellite telemetry. Each spike, each drop, could mean everything. They watch, not in fear, but in reverence. Because what they are witnessing is not chaos. It is the slow, deliberate rhythm of the Earth's breathing. The red alert remains. For now, Yellowstone sleeps in uneasy peace. No eruption, no explosion, just the steady heartbeat of magma deep below. Yet that uncertainty weighs heavily. For scientists, it is both thrilling and terrifying to study a phenomenon that could, in one moment, change human civilization. Outside, the world holds its breath. Towns near the park stay alert. Emergency drills continue quietly. And somewhere out there, a child gazes at the stars above Yellowstone, unaware that beneath that same patch of sky lies one of the most powerful engines in Earth's history. This is not the end of Yellowstone's story, only a pause between chapters. The magma chamber continues to swell and shift, its immense energy trapped under miles of stone. Whether it erupts tomorrow or in another 70,000 years, the truth remains unchanged. We live on a living planet, one that can destroy as easily as it creates. At sunrise, the park looks breathtaking again. Lakes reflecting golden light, elk moving through mist, geysers roaring into the cold air. Tourists marvel, scientists monitor, and the Earth continues its timeless rhythm. Somewhere below, magma moves. Somewhere above, humanity waits. And in that space between fire and sky, the Earth reminds us who's truly in control.